Santosh here, and today I am going to deliver my lecture number 3 part 2 on sedimentation, which is related to water supply engineering. After long gap, I am delivering this lecture because of my busy schedule in construction works. Let us start the lecture on sedimentation, which is very useful for you for MPSC and civil engineering various examinations. First of all, we discuss what is the sedimentation. You must know this process for any water supply treatment. What is the sedimentation? Sedimentation is the removal of suspended particles by gravitational settling. Sedimentation tanks are designed to reduce the velocity of flow of water so as to permit the suspended solids to settle down at the bottom of the water due to force of gravity. So, force of gravity is important factor in process of sedimentation. So, let us discuss what are the different types of sedimentation. The first sedimentation is the plain sedimentation, when impurities are separated from suspending fluid by action of natural forces alone, that is gravitational force and natural aggregation of settling particles. The operation is called as a plain sedimentation. So, plain sedimentation is only based on the gravitational force. The second type of sedimentation is sedimentation with coagulation or clarification, when chemicals or other substances are added to induce or hasten aggregation and settling of finely divided suspended matter, colloidal substances and large molecules. The operation is called as a sedimentation with coagulation or simply clarification. So, sedimentation with coagulation and clarification are the same processes. So, let us discuss the third type of sedimentation, that is chemical precipitation. Name itself indicates it involves the chemical. When chemicals are added to throw the dissolved impurities out of solution, the operation is called as a chemical precipitation. So, you must know plain sedimentation or sedimentation with gravity. Second is sedimentation with coagulation, or it may be termed as a clarification, and third one is the chemical precipitation. This is very important part. What are the different types of settling zones, or what are the different types of settlings? So, type first is the discrete settling. You know that discrete means individual particle. This corresponds to the sedimentation of the individual particles in a suspension of low solid concentration. This is also known as a free settling, since the particle have little tendency to flocculate or to coalesce upon the contact with each other. Okay, so discrete settling corresponds to individual particles. Second is the hindered settling. It is also termed as a group settling. This type of settling refers rather dilute suspension of particles that coalesce or flocculate during the sedimentation process. Due to flocculation, flocculation is nothing but the formation of a foam or a flake. Particles increase in mass and settle at a faster rate. So, second is hindered settling, and it refers to group. And type third is the zone settling. This settling refers to flocculent suspension of intermediate concentration. Interparticle forces hold particle together, and hence the mass of the particles subside as a whole. So, first it is in individual, second it is in group, third it is in mass. So, zone settling refers to mass, hindered settling refers to group, and discrete settling refers to individual particle, and you must know that. And last one is the compression settling, and this refers to a structure. So, Individual is the first, that is discrete settling. Second is the group, that is hindered settling. Third is the mass, that is zone settling. And fourth is the structure, that is compression settling. So it is easier to know, you civil engineers, what are the different types of settling and what do you mean for that settling. So let us discuss the compression settling. This refers to the flocculant suspension of so high concentration that particles actually come in contact with each other, resulting in a formation of structure. Further settling can occur only by compression of a structure brought about due to weight of particles which are constantly being added to the structure. So for that structures, various particles are added, and due to that weight, that settling occurs, and such a settling is called as a compression settling. So please refer this figure. This refer type 1 is the discrete settling, type 2 is the hindered settling, type 3 is the zone settling, and type 4 is the compression settling. Means first individual, second hindered, that is group, third zone, zone means mass, and fourth is compression, compression means a structure. So at the top you get the clean water region, below that discrete settling, below that hindered settling, this one is the discrete, below that hindered, below that zone, and below that compression. Means first is individual, second is group, third is mass, and fourth is structure. So it is so simple, but you must know the basic for that, and please refer this figure for that various zones of settling or various types of settling. Then we are going to discuss the types of sedimentation tanks. First sedimentation tank is very common and simple one, and which is termed as the quiescent or fill and draw type. Name itself indicates we have to fill the water and we have to draw the water. In this type, sedimentation tank is first filled with the incoming water and allowed to rest that water for a certain time. Certain time is called as a detention period. You must know the detention period. During this rest or detention period, the suspended particles settle down at the bottom of the tank. Generally, a detention time, means that is rest time, is 24 hours is allowed. So 1 day is the detention time for quiescent or fill or draw type of tank. At the end of the period, the clean water is drawn off through the outlet valve. This tank is cleaned of settled particles and filled again. The cleaning may take about 6 to 12 hours. The cycle of operation means 24 plus 12, that is 30 to 36 hours. This figure shows the planes and section of such a tank. A minimum of 3 such units are provided to maintain the constant water supply to the city or a town. So please look at this figure. This is inlet, this is the outlet, this is the plan, and if we draw a section of this tank, this is the wall, this is another wall, this is the inlet section, this is the water level, and below that sludge. The particles which are settled down below the sedimentation tank is called as a sludge. So you must know what is the sludge, and this is the outlet, and this sludge is removed with the help of various equipment. So you must know that. Okay. Then second type of that sedimentation tank is the continuous flow type of sedimentation tank. Name itself indicates the flow is continuous. The water is not allowed to rest, but that flow of water is continuous. And there are two types of continuous flow type of tank. One is the horizontal flow and second is the vertical flow. Means in continuous flow type of tank, the velocity of water or velocity of flow of water is one which can be easily controlled. In continuous flow type, water continuously keep on moving in the tank, though with a very small velocity, during which time the suspended particles settled at the bottom before they reach to the outlet. So the velocity in continuous flow type of tank is designed in such a way that the particles are settled down at the bottom of tank. There are two types of that, as I discussed earlier, horizontal flow tank, and second is the vertical flow tank. In horizontal flow type, the tank is generally rectangular, having a length at least equal to twice the width. That is very important. Such a questions are asked in MCQs. What is the length and breadth ratio in a horizontal flow type of sedimentation tank? You must know that the length of such a sedimentation tank is at least twice the width of that tank. The water flow practically in the horizontal direction with a maximum permissible velocity of 0.3 meter per second. So you must know this velocity 0.3 meter per second, which is required to design the continuous flow type of horizontal tanks. Vertically flow type of tanks are generally deep, circular and rectangular basins with hooper bottom. Then we are going to discuss in detail that horizontal flow sedimentation tank. In this design of horizontal flow tank, the aim is to achieve as nearly as possible the ideal condition of equal velocity at all points lying on each vertical in the settling zone. The design of horizontal flow tank is based on the following assumptions. Here is that figure which shows all the settling zones, and this is the inflow zone, water comes from inflow. Then this is the direction of flow, this is the settling zone, then this is the outlet zone, and there is outflow, and at the bottom there is a sludge zone. So you must know the inlet zone, you must know the settling zone. In settling zone there are various types of settling, that is discrete settling. You must know that discrete settling. Then you must know the group settling, you must know the structure settling, and this is the outlet zone. What are the assumptions in design of such a horizontal flow type of tank? Within the settling or sedimentation zone, the particles settle exactly in the same manner as they do in the quiescent or fill or draw type of tank of equal depth. That is important. The flow is horizontal, steady, and the velocity is uniform in all parts of settling zone for a time equal to the detention period or rest period. The concentration of suspended particles of each size is the same at all points of the vertical cross sections of the inlet end. A particle is removed when it reaches to the bottom of settling zone. That are the assumptions. Okay. Then here is one table which shows the common surface loading and detention period for various types of tank. For plain sedimentation type of tank, the detention period is 3 to 4 hours. For horizontal flow circular sedimentation tank, the typical design values for detention period is 2 to 2.5 hours, and for vertical flow type of tank or clarifier, it is 1 to 1.5 hour. We calculate the surface loading by formula Vs is equal to Q by A. You know that velocity is equal to discharge divided by area, and detention period, that is equal to V divided by Q, that is V volume means L into B into H divided by Q is the discharge. So you must know these formulas. You study all these formulas for the exam, and you must know that for plain sedimentation we can remove the sand, silt and clay. For horizontal flow type of sedimentation tank we can use the alum, and we can remove the fine particles or iron flows. And for vertical flow type of tank, flocculants are used. So you must know that alum, where it is used horizontal flow, flocculant vertical type of, and sand and silt and clay, that particles are normally removed during the plain sedimentations are the sand and clay. For horizontal flow, alum and iron floc, and for vertical flow that is all flocculants. Then we are going to discuss the plain sedimentation process. Plain sedimentation tanks where only gravitational force is dominant, rectangular tank with horizontal flow, circular tank with radial or spiral flow, and third type of tank is the hooper bottom tank with vertical flow. So horizontal, vertical and spiral flow, and rectangular, circular and hooper bottom, you must know these three different types of tanks and their similarities and differences. Rectangular tank with vertical flow. In many of these tanks, baffles are provided. Baffle means wall within that sedimentation tank with object of preventing the short circuiting. Such a tanks has and also to reduce the velocity of water. Such a tanks has a high settling efficiency. It is provided with mechanical sludge removal equipment. We have to remove that sludge with mechanical equipments. The sludge is scrapped by sludge scrappers, is collected in the hooper form where it is removed through the sludge withdrawal pipe connecting to a sludge pump. You must know that process. Please see this figure. This is the inlet channel. Water flows into the tank and this water is travel through this tank, and this is the baffle wall. This is the baffle and water is traveling in this process, and such a type of tank is called as a plain sedimentation tank, and this is the rectangular tank with horizontal flow. Then circular tank with radial or spiral flow. Name it itself indicates the tank is circular, and these are costlier to install. They are convenient for installing the mechanical sludge scrappers. That is the advantage. For circular tank, we can easily install the mechanical sludge scrappers. The circular tank may have radial or spiral flow. The path of water in such a cases generally forms a distributor at the center to decanting weir at circumference. Influent enters through a central pipe and rises up to a baffle box or influent well, from where it flows radially towards the circumference. The outlet channel is provided at the circumference. The racking arms move slowly to scrap the sludge, which is removed through the sludge pipe connected to the sludge pump, as that of rectangular tank. Please look at this figure. These are the raking arms. These arms are the raking arms. This is the outlet channel, and these are the blades, and there is a sludge pipe. That sludge which is collected at the bottom is removed with the help of pump through the sludge pipe. So you must know that this is the influent and this is the effluent. Influence means incoming, effluence means outgoing. Okay. Then third one is the hooper bottom tank with vertical flow. Water enters through a centrally placed inlet pipe, and water is deflected downwards by the action of deflector box. Water travels vertically downwards. The sludge settles at the bottom of the hooper, from where it is removed with the help of sludge pipe, which is connected to a sludge pump, as that of normal. So this is the inlet channel. The water is here, and that water goes vertically downwards, and it is deflected with the help of that deflector boxes, and sludge is collected at the bottom, and that clean water or effluent are collected here. So this is so simple, but you must know that figure, and you remember all these figures, my dear friends. Then we are going to discuss the sedimentation with coagulation. That is nothing but the sedimentation, but some coagulants are used to activate the coagulation process. The efficiency of plain sedimentation is generally low, especially when water contains suspended matter and colloidal matter. The coagulants neutralize the negative protective charge on the colloidal particles and allowed to coagulate. That is very important. Coagulate, neutralize the negative protective charge on the particles, colloidal particles. The chemical added for this purpose also convert the impurities which may present in the solution. Colloidal suspension or in a finely divided form into particles which are of such size that they may be readily removed by settlement. The chemically assisted sedimentation comprises several separate processes of treatment make up the complete system known as a clarification. So sedimentation with coagulation must be added with clarification, and it is achieved in the 3 stages. First stage is addition of the chemicals to the water. Then second is the formation of precipitate which coagulates and forms a flock or a flake. Third is the sedimentation. So sedimentation after coagulation is called as a clarification. You must know that difference between clarification and coagulation. Factors affecting the coagulation and common coagulants. Factor affecting the coagulations are the type of coagulant. If different types of coagulants have different properties, so that is the factor. Then quantity or dose of that coagulant, that is very important. Then characteristics of the water is also important. Type of water, quantity of suspended impurities, temperature of water, pH value of water, all are the important. And also time, velocity of water and method of mixing is also important. Then common type of coagulants is aluminum sulfate or alum. It is very favorite. In Marathi it is called as a tulti. Tulti is very effective coagulant. Second are the chlorinated coppers. Third is the ferrous sulfate or lime. Then magnesium carbonate is also used. Then polyelectrolytes are also used, and sodium aluminate is also used. So you must study all these coagulants, and you must study which is the effective in which situation. So you must know the different types of coagulant and which coagulant is used in which situation. It is very important. But as far as water supply engineering is concerned, you must know the aluminum sulfate or alum. Okay. Then flocculation. Flocculation is generally an operation designed to force agitation in the fluid and induce the coagulation. Basically, flocculation is the slow mixing or agitation process in which destabilized colloidal particles are brought into intimate contact in order to promote their agglomeration. Slow mixing is the hydrodynamic process which results in formation of large and readily settleable flock, and by bringing the finely divided matter into contact with microflocks formed during the rapid mixing. The operation of slow mixing is achieved in a basin commonly known as a flocculator. So flocculation is the process of agitation or to force the agitation of the fluid and to induce the coagulation. That is very important. Flocculation is merely the provision of the type of controlled motion or agitation of water which will assist in formation of settleable caused by the agitation of water, increases the probability of collision between these nuclei and accelerates the rate of growth into large particles which can settle easily. So that process is also flocculation is also one type of sedimentation process. So you must know this figure, from where the chemicals are fed, from where flush mixture is provided, where are the flocculators. You must know that baffles are provided in this process. There are clarifiers are also provided, and where influents are added and where effluents are taken. You must know all that, and sludge is collected at the bottom. So in short, sedimentation हे तुम्हाला मराठीत सांगतो. मराठीत म्हणजे एखाद्या टँकमध्ये किंवा एखाद्या विहिरीमध्ये किंवा एखाद्या कुठल्याही कंटेनरमध्ये जर आपण पाणी ठेवलं आणि त्या पाण्याला तसंच ठेवलं तर ते पाण्यातले पार्टिकल जे असतात सस्पेंडेड कोलायडल ते पार्टिकल हळूहळू सेटल डाऊन होतात आणि जर ते पार्टिकल सेटल डाऊन होत नसतील तर केमिकल किंवा वेगवेगळ्या प्रोसेसेसच्या साह्याने त्या पार्टिकलला खाली कसं बसवायचं ही प्रक्रिया म्हणजे सेडिमेंटेशन. सो दॅट इज सेडिमेंटेशन अँड यू पीपल must got the idea of sedimentation. So this is enough in this lecture, and I am again requesting you to subscribe my channel for MPSC and civil engineering examinations and to get the ideas clear in a simple manner. So thanking you.